Welcome back to Mr. Algebra. For this video, we're going to show you an introduction to polynomials, but we're also going to show you how to do some addition and subtraction with them. Here's what polynomials are. They're expressions consisting of variables and coefficients that involve only the operations of addition, subtraction, and multiplication. They also have non-negative integer exponents. A couple examples here would be x to the first power, and that is to the first power. Even though I don't see an exponent on there, that is really x to the first power. 3/4 x to the second power plus 2, that's another example. And then we've got 8a cubed plus b squared minus a squared. So those are all examples of what polynomials look like. Some things that are not examples, this next one here, we have 3x to the negative 2 power plus 4. So this negative 2 exponent right here, this is a negative integer, makes that not a polynomial by definition. Also, you can see we have a division down here of a variable, and if you look back up here at the top, these operations are add, subtract, and multiply. They are not division. Now that doesn't count right here. This is a division of two numbers, not a division of a variable like we do down in the bottom. So that makes that not a polynomial. Also, polynomials cannot be under radicals. That goes back to the non-negative integer concept, which we'll explore later on. Here's another little refresher of the parts of a polynomial. Right here we actually have what we call terms: 1, 2, 3, 4. These are 4 terms. You'll notice that they're separated by plus and minus signs. And the number out in front is the coefficient. Now this one's called the leading coefficient because it has the largest exponent, and that exponent is called its degree. And this is what we call standard form. We'll talk about this again later in the video. But the highest degree, the number out in front, is called the leading coefficient. Now the coefficient of the next one is a 1. The coefficient of the next one is a negative 5. And the last one's called a constant term. That's the one, any number that doesn't have a variable attached to it, and we call that a 0 degree. Okay, so we want to put these in standard form, and standard form is in order of decreasing exponent. So what we want to do is find the largest exponent, which is this one right here. What that means is my leading coefficient is actually going to be negative 5 no matter where it's found in the problem, because it's attached to the largest exponent. But I do want to put these in order. So technically we should take this negative 5, negative 5c to the fourth, put that first. Then we find the next highest exponent, which happens to be this c to the third, so we'll bring that down, and notice that the signs are following them. So the 5 had a minus in front of it, but it's technically a negative power, or negative number when we bring it out front. And then the next one would be a power of 2, so that goes next. And then the last thing on there is the 10, so the 10 goes last. Now the 10 doesn't have a operator in front of it, so I'm going to add one because it's a positive 10. I'm going to put a plus 10 there. And so this right here is what we refer to as being in standard form. Okay, this polynomial chart does a couple of things. It classifies our polynomials 2 ways. First way is by the degree, and the second way is by the number of terms. Let's try that again, by the number of terms. Now the degree is just the exponent itself. That's the numbers. The words next to it is what we refer to it. If it's 0 degree, we call it a constant. If it's first degree, we call it linear. If it's second degree, we call it quadratic. And those mean the same thing. And then you can see we have some examples there. So the constant was a 6. The linear had a power 1, even though we don't see it. There's still 1 there. Quadratic has a power 2. And a cubic, and this is going to be mostly the highest one we go through, is cubic. The highest degree, the highest exponent is a 3. Even though there's a 2 right here, 3 is higher. So this is called a cubic, and because that is part of the largest exponent, this 2 out in front becomes the leading coefficient. Okay, quartic, we might see a couple of those, 4th degree, and usually we don't go past that, and you can see there is a quintic on there, which is 5th degree. Now we could also label them by their terms, number terms. So the constant term had only 1, so it's called a monomial. This linear expression, first degree, had 2 terms. We call it a binomial. This quadratic, which is right here, only has 1 term, so that's a monomial. So we can call it a quadratic monomial, so you can name it both ways. This cubic down here has 3 terms. We call it a trinomial. But by the time we get back up to the quartic, it only has 2 terms separated by 1 plus sign, so it's back to a binomial. So it is a quartic binomial. Typically anything over 3 terms, which is trinomial, we just refer to it as how many terms the polynomial has. Polynomials are also closed under the operations of adding and subtracting, multiplying. If you were to, what that means is if you were to add or subtract or multiply a polynomial, you will always get another polynomial out. If you end up getting a non-polynomial out, then polynomials are not closed under whatever operation you just performed on them. For our first example here, we're going to show you how to add polynomials. And the one thing you want to be aware of is if there's anything in between this plus sign and the parentheses here, any kind of number there, especially if this is a negative, you have to distribute that out all the way through. Same thing goes for if there's anything up in front. What I like to do, you can add them side to side like they are, but what I like to do is rewrite these vertically, stack them vertically. Now you can only combine your like terms together. Those are the ones that have the same variable with the same exponent. So what I'm going to do is I'm going to look at this first one. My highest degree here is a 5x, so I'm going to bring that 5x down. Then my next highest degree is this plus 4x squared, and you'll notice that it goes from 3 to 2, so I'm going to leave them side by side. If I miss anything, then I'm going to fill it in with a 0 or a blank, and then from 2 to 1 I have a minus 2 like this, so I'm going to stack those there. So 3, 2, 1, they're in descending order. I'm not missing anything. I'm going to come back to this one. Now since there's a plus here, I distribute a plus 1, this actually drops. The parentheses drop and go away. So I'm going to take my highest degree, which is this 3x, and I'm going to bring it underneath my 3x or my 5x to the third power. I can only combine these together because they have the same variables, the same exponent. Then I've got this x squared is my next biggest one. I do have one that matches up underneath it. And if there was a negative sign, I got to make sure it comes down as well. Now right here, I do not have, in my second expression, I do not have a power of 1, so I'm not going to put anything there. I'm going to bring this negative 6, which says 0 degree, and place it over here. And then to be able to add these together, I'm going to draw a line like this. I'm going to put a placeholder of plus 0x and then plus 0 here, because all I'm going to do with these two things are add them together. So I'm going to add them up vertically. 5x to the third plus 3x to the third is 8x to the third. 4x to the second plus 4x to the second is positive 8x to the second. And then I've got a negative 2x plus 0x is negative 2x. And then 0 minus 6, or 0 plus negative 6, is negative 6. And this right here becomes my simplified addition. Okay, for this next example, we have a subtraction problem. One thing you got to be aware of is this minus sign will affect all these signs in here. But I'm going to leave the minus on the outside of my parentheses. You'll see what I'll do here in a moment. So I'm going to go back to my first one. This one always goes on top when you stack these. I like to stack these. So the highest degree here is a power of 2, so I'm going to pull that down first. Now I don't have a power 1, so I'm going to leave a space here, and then I'm going to bring down my minus 7. Now for my next one, I'm going to go to this next one here and find the highest degree, which is a power 2, and I'm going to stack it right underneath it. Then I got a power 1, which goes in this blank here. I need to move that over a little bit. And then I've got this minus 9. And here's where you have to be really careful. I do want to subtract this, so I'm going to put a bar here. I'm going to put parentheses around the outside and put a minus inside here. And I'm also going to put a placeholder of 0x to the first power here. And then I'm just going to read this off. 4 minus 5 is going to give me a negative 1x squared. So 4x squared minus 5x squared is going to give me a negative 1x squared. Then I've got a 0x minus a 4x, and that's going to give me a negative 4x. And then I've got a negative 7 minus a negative 9. Well, minus a negative is really plus 9, so negative 7 plus 9 ends up being plus 2. And this ends up being our difference, and because I already stacked them from highest to lowest, it's in standard form.